No, I don't want that. Wait. Oh, okay, it's on. Okay, let's see if you remember this. The modern table, what are the elements in order of? Atomic.
Number.
Yeah, that's the bold number. And what does atomic number also mean? It means the number of protons. And this will definitely be a question. Which element is most metallic? Now we're going to look it up. Iodine, chlorine, bromine, and fluorine. So we have to go here. Oops. Iodine, bromine, chlorine, and fluorine. See how they're all in the same group? They're all in group 17 here. So when you're going to guess one of the extremes. But anyway, oh, I don't know why I have this twice. Most metallic is the one at the bottom, because the lower left is most metallic, even though these are all nonmetals. So it's a very confusing question. Now in period 2, as you go left to right, what is there a decrease in? Well, I'm just going to pick metallic character because you're going from metals to non-metals, so metallic character will go down. Now you could look up ionization energy on table S and you'll see it gets higher as you go across, but we're going to move on here. Now, compared to the covalent radius of a sodium atom, the covalent radius of a magnesium atom is smaller. Why? Let's look up sodium and Mg. It's asking about principal energy levels. Okay. I keep picking the wrong thing. Where is periodic table? Here we go. So you see how sodium and Mg are in the same group over here? I mean, not same group, same period. That's 281, 282. So they both fill the same energy level here. They're both in the third energy level because they're in period 3. So that's not going to be the question. They're both in period 3. But when you look up the atomic number, Mg has a larger nuclear charge because you have to know nuclear charge means protons. Okay? Which element in period 4, so we're going across period 4, has the most non-metallic properties? So let's go to period 4. And I don't know why this part's cut off here. I can't even get in. 1, 2, 3, 4. All right, period 4. This is period 4, this whole row here. So non-metallic, you don't pick the last column. You don't pick the noble gases. So I'm going to see if BR is a choice. Because these are just the trends you have to, like, memorize. So, yeah, BR is a choice. And again, you're going to pick a guy at the extreme. Where are the strongest metallic? Metals are lower left are the most metallic. Now here you want increasing radii. I know down a group, the radius gets bigger, and I think this one, FCl, Br, and I. You see right here, FCl, Br, and I. But if you want, you could actually go to the, right here to this table S, and you could look up that the radius of each and see what happens with the numbers. Okay, so F, if we look up F, it's a 60. And if you look up I, you would take the time and look it up. I guess, is on the other page. I'm looking up the first guy and last guy, 136 over here. So you see that the radius got bigger. It went from 60 to 136. I keep picking the wrong thing. So that definitely got bigger. Which two have the most similar chemical properties? Well, you want the same valence electrons, which means same column. This is definitely going to be on the test. So I'm going to show you that Na and Rb are in the same, here's Na, and Rb is right here. Same group, have similar chemical properties. Good?
Yes.
Now, here, Li, Na, and Rb, we're going down a group. When you go down a group, the radius gets bigger. And you could even, because there's more shells, you could look it up. I'm not going to do this one. It's really hard, but you could look up the answer later. What are the elements in order of increasing?
Atomic number.
Yeah. And which is the noble gas? You pick group 18 and Kr, krypton. If we look, you pick any element. And group 18, they're noble gases, and here's krypton right there. And then, so periodic table questions, you're going to look it up, but your teacher didn't even give you a periodic table, so you wouldn't even know, here, same as magnesium, you wouldn't even know where to go. Magnesium and calcium, if you go to the table, Magnesium and calcium are in the same column, same group, so they're considered same family, and they have similar chemical properties. Do you remember the two liquids you had to memorize for the periodic table? Bromine is the non-metal liquid, and mercury is the metal liquid. Those are two you have to memorize, the two liquids. Now here we want a non-metal, so we're looking up Br, and they want to know what group. So let's see. Br is in group, I kind of like wrote over it. Right here, group 17 has Br. So they're asking which group. And it's going to be 17. Two groups which have the most similar in their chemical properties. I don't think they can ask this one. I don't know why I put it on. Groups 1 and 2 don't exist in nature because they're so reactive. They exist as compounds, so they're similar in that way. But here, who has the most similar chemical properties? What do you want to be in the same group? So you're going to have to look at them all. Let's look at N, O, and F. Because they trick you here. See how they gave you the same period? That's not the answer. But the other one said L, I, N, A, and K, which is in the same column, and that's going to be the answer. Same group, similar chemical properties. Now, and I'm not going to do any more similar chemical properties, but group 18 are called monoatomic gases or noble gases. This one, they want to know M2O. You're going to probably get one of these. Which oxide would that be? Well, if you crisscross backwards, the O gets the 2 charge and the M gets the 1. And if you look at group 1, they have, I kind of went over it, +1 charge. All right, next one. Why is sulfur group 16? Let's look at group 16. How many valence electrons does sulfur have in group 16? That's the last number. Has a 6. So let's see if that's a choice. 6 valence electrons right there. I don't know why I did so many similar chemical properties thing. I do want to do this one again, where you put a 1 here and a 2 here, and you work backwards. So X got a 2, and F got a 1. So X has to be a group 2 metal, because if we look, it's a metal and a non-metal when you combine these two. And if you look, which has a +2 charge, it's the group 2. And then you see, these could be very challenging. This over here. Which period contains 3 elements that are diatomic? You have to know all the diatomic elements, and here they are. There's 7 of them. And we want the period with the 3, and it's right there, N, O, and F. And if we look, what period is that? This is period 1, period 2, period 3. So it looks like it's period 2 has N, O, and F. But you see how you have to really refer to your table? What do periods 2 have? Same number of occupied principal energy levels, because they're all filling the second shell. And if we look at that, you see how period 2 has 2, 3, 2, 4, 2, 5, 2, 6. So it's filling that second shell. And then which element in period 3 is diatomic? Well, chlorine is diatomic. Let me make sure that chlorine's in period 3. Yeah, 1, 2, 3 right here. So you have to memorize that. And then if you're in the same period, you have the same, you fill in the same principal energy levels. I think P for period, P for principal energy levels. Which element in period 3 is unreactive? It has to be a noble gas in period 3, so you have to make sure you pick the right one. So here's period 3. The noble gas is Ar, which is argon. How many valence electrons in calcium? Well, you're going to look up calcium, 2882. So the last number is the answer, and I'm just going to show you calcium. You see it here, 2882. So valence electrons is that last number. But you notice half this crap you're going to look up. More than 2/3 the elements are
metals.
Good. Which is a metalloid? You want to be on the stairs. Those are the ones that have properties of both metals and non-metals. You're definitely going to get one of those. But here, like these guys, not aluminum. These guys, Okay, and then right there. So now we're looking for these guys. So the answer is TE. If you're not sure TE, you go to table S and you make sure that that's the name. Here we want a metalloid and noble gas. So we need group 18 and the stairs. And I'm telling you it's going to be this, AS and AR, and I'll show you. AS is on the stairs and AR is right there. Good?
Yes.
I just want to close this up. Periodic table, so damn boring, right? And then elements appear for group 1. What are they classified as? Let's look. Group 1. Well, group 1 over here is definitely a metal, just not H. So metal. Group 14, period 3. Let's go look that up. Group 14 is right here. And then that's 1, 2, 3. So it looks like it's silicon. So what are they asking about it? Oh, metalloid. So you gotta be careful. Which contains a metalloid? AS before I saw was a metalloid. You want to be on the stairs. And that means properties of both non-metals and metals. I know silicon is a metalloid. It was on the stairs. What do we know about non-metals in the solid state? Do you remember a property of them?
Yeah, brittle.
Yeah, these are all the properties of metals. They're malleable, which means they can be hammered. They have shine, and they're good conductors. But non-metals are brittle. Non-metals are poor conductors. And we could look up their ionization energy, but it's actually high. All you have to do is pick a metal, pick a non-metal, pick a guy on the left and the right, and then you go here, and you could look up their either ionization energy or electronegativity values and see if it's higher or lower. Yeah, I feel like because your teacher didn't even give you the periodic table, you don't even know how to utilize it. Non-metal solids, there's that keyword again. And we know they're poor conductors and high ionization energy. When we want good electronegativity, you want to pick a metal. Yeah. Malleable means a metal. Anything to the left of the stairs. Which element is a solid? Okay. Oh, you have to memorize. I spell the word is for iodine. Iodine is the diatomic solid. It's the only one. Bromine's the diatomic liquid, and then the rest are all gases. So which one was the liquid? Bromine. Gas, solid. Which element is a metal that's a liquid?
Mercury.
Good, mercury. Which element has a definite shape and volume? That's the definition of a solid. And actually, mercury's a liquid. And these guys are in group 18, so it's silver. Group 18 are called noble gases. I know I'm not showing you, but I don't want to go back and forth. This is a diagram of a solid. So these are the diatomic gases. Krypton's in group 18, which is called noble gas. And all metals are solids except for mercury. Now, which is a gas? Why do I know xenon? Because if I look, group 18 right here are called noble gases, the last column. And then this one, metal M is obtained from a rock sample. What phase is it? Well, if it's a metal, I'm going to say solid. Most of the elements are solids anyway. Now, xenon is a noble gas because it's in group 18, so it looks like this, a gas. If they asked you hydrogen gas, you'd have to know it's diatomic, and it would be that one. You see how oxygen and ozone are different forms of the same element? They have different structures, and that means they have different everything. Even solid forms of carbon. Carbon, oxygen, and phosphorus, I spell the word COPS, they differ in everything. Their structure, S for structure, and property. Here's another one, COPS, carbon, oxygen, phosphorus. Here they're telling you about ozone's different structure. And just pick different structure, different properties. Carbon could exist as graphite or diamond. They have different properties and different structure. There's carbon, oxygen, phosphorus. Different structure, different properties. Two forms of carbon. Why do they differ in properties? Due to their S for structure. You're definitely going to get one of these. Here's the COP thing again. I just picked different without me even reading it. Different. It's talking about carbon again. Even here's phosphorus. It comes in different colors. But what do we know? Different structure, different properties. different structure, different properties. That's what you're going to pick. If M is in group 2, chlorine, you look up the charge, and I'll show you where that is. Chlorine, you pick the first one on the list, which is the -1 there, and then you crisscross. So Mg gets a 1 and Cl gets a 2. I mean, M gets a 1, I said Mg. M is an alkali metal, that's group 1, they have a +1 charge, and then it's formed with oxygen. So let's look. +1 for group 1, and then oxygen's a -2. You look up their charges, and then the 2 goes down there, and the 1 goes there. So it's M2O. Good? An unknown is with XBr3. Work backwards. The 3 went here, the 1 went here. Group 13, if you look it up, they want to know what's the charge. Group 13, if you notice, they all have a 3 charge. And then YNA is not found in nature because it's found as a compound because it's very reactive. Here's another one where they want to know what the charge of element X is, and it looks like it's a 1, and group 1 has a +1, group 2 has a +2. Where's the most active nonmetals? Upper right, don't pick the noble gases. Lower left is the metals, but upper right is fluorine is the most active non-metal, which is inactive and contains a triple bond. You have to memorize nitrogen forms a triple bond with itself. They might ask you that. You just study this stuff. What doesn't react? Group 18, the noble gases. Chemical change, you're looking for like bubbling, burn, react. I don't know if they went over this with you. Corrosion, rust. So it was that answer. Chemical property, react. Whether it conducts, whether it could be hammered into sheets and the or its boiling point, that's physical. Chemical property, you're looking for the word burn. I would read the other ones later to see. Oh, this is definitely going to be on your test. Attraction for electrons. Do you remember what that's the definition of?
Metal.
Electro. It's true that metals have mobile electrons, but this is, they want electronegativity. And I know them by heart, so to save time, I showed you earlier how to look them up. Strongest is this one. Greatest tendency to attract electrons. What are they looking for? Electronegativity, which you're going to look up each value, but his is the biggest here. Here they asked who has the highest electronegativity, so you look them up. It's going to be the non-metal. These guys are less than 1, but I'm not going to bother because I showed you earlier with bonding. Now, this is water and this is hydrogen peroxide. They're different, but they're different compounds. You don't pick mixture. Mixture, you need AQ, not liquid phase. So these are out. You only pick mixture if it says AQ. What's the definition of attract electrons? Out of the choices here?
Electronegativity.
Yeah, gaining. It's right in the word, gain electron. And then, what is the trend in period 2 as you go this way? So let's just pick, let's go to period 2. This is period 2. We'll pick Li and F. Okay, so I'm going to write down Li and F, and I know his electronegativity. He's 4.0. So I'm going to look up Li's electronegativity. Li is a 1.0, right? So he went from 1.0 to 4.0, so electronegativity went up. And then we want to look at the radius, but why memorize? All you have to do, let's see, Li's radius, because this column here is radius, so Li is the third one on the list, is 130, and F is actually 60. So it went from 130 to 60. So what happened to the radius? It went down, right? So the electronegativity went up, but the radius went down. So you look it up. You're definitely going to get this question Friday. The amount of energy required to remove an electron, that's the definition of ionization energy. So here it's saying which has the least tendency to lose an electron. So you're going to look up ionization energy, okay? And then at least you want the lowest number. The answers are at the end, so I'm not going to do that one. which requires the greatest amount of energy to remove an electron. So you want the one with the highest ionization energy, because remove an electron is ionization energy. Now, when you do +3, that meant you lost 3 electrons, and you're smaller. What about barium? Let's look at barium, what type of ion it is. Barium becomes +2. So the ion is smaller because it lost electrons. Same thing here, Mg plus lost electrons, so its radius is smaller. Here you gained an electron, so it's bigger radius. Why the radius of lithium is larger than the ion? Because metals lose electrons, so they get smaller. Chlorine becomes Cl minus when you look it up. So chlorine got larger because it gains. You're definitely going to get, that's why I'm drilling this. P minus 3 means you gained 3 electrons, so the radius gets bigger. Man, how many problems did I put here? Okay, this one. Compare the radius of an ion to an atom. Well, what does the +2 mean? You lost 2 electrons, so the radius decreases. Whenever they say compare on open response, the answer is either higher, lower, or the same. So you have you could just guess. I went through that fast. It took 21 minutes, but